Okay, let's get started, this final panel session. So good afternoon, I'm Nigel Shadbolt, and I'm both the principal of Jesus College, so it's great to have you all here in college, and also a professor of computer science at the University of Oxford. I'm delighted to be chairing this final session of the Creative Machines Symposium. And today we literally have brought together invited speakers from the worlds of computing, AI, art, robotics, and virtual and augmented reality. We've looked at topics ranging from can AI be creative, to AI's use in scientific visualization, for discovery, AI for music, human intelligence, and indeed the working of the human brain, and analogies and disanalogies between that and our AI systems. Our panel today is entitled AI Impact and Implications for Society. Pretty broad topic that. We're going to range seamlessly over it, hopefully, and I'm delighted to be joined today by Jacomo Corbo, who is the co-CEO of PhysicsX, with a background in using AI for solving engineering problems and the use of machine learning in many contexts. Previously founder and chief scientist at Quantum Black, acquired by McKinsey, advanced analytics firms where he focused on applying AI to improve the quality and scalability of client delivery. Passionate about helping organizations adopt AI at scale. Formerly, actually early in his career, the one fact I know you'd be interested in, he was actually chief race strategist for the Renault F1 team from 2006 to 2008. Corbo holds a PhD in computer science from Harvard University. Then Marina, Jirotka, our professor of human-centered computing at the University of Oxford, who is particularly interested in integrating human and social values in the design and use of technology. She's director of the Responsible Technology Institute, and she's at the forefront of researching and promoting responsible innovation, exploring a range of ICT fields, including robotics. John Tasioulas, moral and legal philosopher, currently serving as the inaugural director of the Institute for Ethics in AI and professor of ethics and legal philosophy at the University of Oxford. He's held prominent positions in academia from Glasgow through to the University College London, and was in fact the inaugural Yeo Professor of Politics, Philosophy and Law at the Dixon Poon School of Law, King's College London. John's work ranges broadly across issues to do with the ethics of robots and AI, international law, and much more, as we'll see. So I thought I'd just set a little bit of framing here. Our various histories in AI. I've been working in AI for a number of decades now, in fact, more than I care to remember. And I remember, what I do remember very clearly is beginning my PhD, or DPhil as they call it here, up at the University of Edinburgh, at a time in the late 70s when they were busy trying to close it down. The Lucasian professor of mathematics, James Lighthill, had determined that AI was hopeless, ill-conceived, and misdirected. Well, it may have been some of those things at the time, but fortunately it survives James' attempt to shut down all of AI. There were, through the decades that followed, cycles of enthusiasm and despair, hope and disappointment as AI both advanced and hit various barriers. About every 10 years, a notable aspect of human problem solving or human expertise would be mastered by the systems of the day. And we have these extraordinary images of Garry Kasparov being literally undermined by Deep Blue, or Lee Sedol, the world's great Go player, being beaten by AlphaGo. Periodically, AI achieves what had previously been thought to be speculative in the realms of science fiction, but then often leads to over-claims about its impact on everything from jobs to dehumanization, safety, ethics, transparency, and accountability. What is interesting about the current enthusiasm for AI is just how pervasive it seems to be. Almost every day, there are commentaries and views on the news, in our newspapers, from commercial companies, the public sector, from government, proclaiming a new age of AI, a new potentiality, much of that, of course, powered by developments in generative AI, some of which we've been discussing here today. The extraordinary increase in the exponents of computing that has led to million-fold increases in compute power, to exponential decreases in the effective cost of that compute power, and a huge amount of available data. And yet still we feel there is an extraordinary mismatch or impedance between the technology on the one hand and our human dispositions on the other. And how are we to bridge that, how to understand the implications of these developments on our society and for ourselves? So I'd like to explore these issues with our panelists. I'm going to go to Jacomo, first of all, and ask him to just, you're very much from the point of view of engineering and the deployment of these methods. Give us a little bit of your sense. I'm going to ask each panelist to talk for a little, up to about 8 minutes, on what they see the major drivers of the AI impact on society from their perspective. So from an engineering perspective, from an AI practitioner perspective, Jacomo.
Maybe in the first place, it's worth making a definitional point, which is, maybe this is the first time that this is relevant and germane to distinguish between, let's say, artificial intelligence and machine learning. And I've always preferred the term machine learning. And for most of my career, most of what we've been doing in, let's say, a B2B context, working in enterprise, looking at the enterprise deployment of machine learning, these are things that bear, let's say, no semblance whatsoever to, artificial intelligence conceived as anything approaching artificial general intelligence. But we're all of a sudden in a world where maybe we need to make that distinction a little bit in the generative context. Now, I think it's worth saying that at the level of the engineering itself, how these systems are implemented, we've seen, a few big evolutions over the course of the last 10 years. And that's really at the level, at the level of the requisite infrastructure, our patterns for actually developing these, at the level of language in which these models are instantiated, and ultimately, how they're deployed into production, so how they work as production systems. And over the course of the last 10 years, maybe until relatively recently, a lot of the focus was on modeling formalisms that would work well in a very specific task. And what would work well in one, for vision tasks would look quite different to what worked well in language tasks, would look quite different to what worked well in, in robotic control tasks. The architectures for, a recommender systems would bear very little resemblance to what work, to any number of NLP tasks, natural language tasks. And the thing that has changed maybe in the last few years, and really starting in 12, but progressing across many different tasks in many different fields, has been the advance of deep learning, and how we've gotten to a place where actually, and some of you will know this, fascinating paper, which I think epitomizes this trend, which is a paper by DeepMind called Gaucho. And this is, a single architecture. Think of it as a single monolithic architecture that was trained on about 250 very different tasks. So across vision tasks, robotic control tasks, some NLP tasks, and a number more. And what they managed to do in this single large transformer model is to achieve close to state-of-the-art performance across all of these tasks very separately. So we're not talking here about, state-of-the-art performance on unseen tasks, but still achieving state-of-the-art performance on all of these tasks for which it was trained. And I think, this isn't, we're not talking about generative AI now, but it is a really salient point, and it really shows one of the fundamental ways in which these systems have evolved, relatively recently, which is to say that we're moving away from a world where a lot of the the advances are happening at the level of architecture and modeling formalisms, modeling frameworks, we're moving into a place where we're just taking advantage of scaling laws. And certainly that's the case in for generative AI. If you compare something like GPT-3 to the original GPT, it's roughly 20,000 times more compute required to train that model. You know, in addition to more hyperparameters, more data as well, but 20,000 times more compute. And a lot of the advances for, you know, models pushing several billion parameters, or, you know, tens or even hundreds of billions of parameters, look pretty similar to, you know, that original GPT model. A lot of the advances are more at the level of infrastructure, the requisite infrastructure to be able to train these larger models, to be able to take advantage of these scaling laws. And the thing that's also maybe happened is that with these scaling laws, we're starting to see emergent behavior, right? Which is something entirely new, and, you know, very different from a lot of machine learning, you know, as we've tried to implement it over the course of the last decade or so, which is these would typically be single task models trained very well to perform on a given task. But if you look at GPT-3, for example, I mean, one, it looks like a recognition of its capacity for few-shot learning was only recognized ex post training. You know, two, its ability, you know, its proficiency with chain of thought reasoning looks like that was only, you know, understood a few months after the public release, right? So we're starting to see, you know, emergent behavior here, you know, performance on unseen tasks that are a little bit unpredictable. And that with, you know, no very clear-cut mechanisms or no, you know, verifiable ways to guide these models to behave in certain ways. You know, whether we're talking about domain adaptation, whether we're talking about, you know, reinforcement learning via human feedback, like all of these mechanisms are ways in which we've worked out how to get at slightly better properties, you know, get at fine-tuning, get a better task performance, but in ways that are relatively unreliable. And I think a lot of the, let's say, consternation that we have with these models is precisely the fact that we don't know exactly how to tune them verifiably. I'll leave it at that.
That's a very good segue into what I think Marina will want to kind of draw attention to. Thank you.
Thank you, yeah. I'm going to talk a bit about responsible innovation, but before I start about responsibility, I thought it might be interesting to just talk a little bit about how I got to doing what I'm doing. So like Nigel, I started many years ago looking at AI. My first project was in the first summer of AI, because there's been lots of summers and winters, as you know. And it was the time when knowledge-based systems and expert systems were around, which had really the idea that you could essentially replicate human expertise by capturing the knowledge through various elicitation techniques. And I think that was Nigel's sort of area as well. So then at that time, we were developing AI systems for a government agency, actually known as the Department of Health and Social Services, for those of you who remember them. And this had a really wide scope, which was to help policymakers to think about the implications of changing policy in the area. It was to help staff to think about calculating benefits for people. And perhaps the most radical part was really developing an AI to help ordinary people claim welfare benefits, which was the bit that I was working on. And what we were doing, we were focusing on the most disadvantaged in society. And a topical area of social science at that time was lone parents. So most unusually at this time, the group consisted of both social scientists and computer scientists working together to develop these innovative systems. And this was when mouse and high-resolution screens were very new innovations. The project was highly ambitious, but from it we were able to design systems and interfaces to actually test these things out with ordinary people so that they interacted more naturally with people. Of course, the implications of developing these kinds of systems, or particularly the welfare benefit one, were too great for the government at the time, potentially allowing people to be able to claim all the benefits that were available to them. But it did allow us to work closely as an interdisciplinary team and with the public as well to develop these systems, but also to start to try to anticipate some of the consequences of giving claimants this kind of information. So subsequently, as I've been involved in many different types of technologies, but those activities have always been interdisciplinary, involving users, social scientists, and many other stakeholders, hence that focus on human-centered computing. And this is actually one of the fundamentals of responsible innovation, or RI. RI came from social scientific concerns that there were problems with some of the ways that science and tech was actually being developed that were outpacing traditional governance structures. Drawing on something then called anticipatory governance, RI tries to anticipate and to prepare for the possible unintended consequences or negative consequences of technology. And it does this primarily through including many voices, being open to other views, including many different types of stakeholders, including the public, to get a better understanding of what the consequences of how technological innovation might impact different areas of society. Then how should it be deployed? How should it be designed and then deployed to mitigate some of these potential negative consequences? So many kind of different definitions have been put forward, but we like the one that came from Jacomo at UCL, which is really about taking care of the future through collective stewardship of science and innovation in the present. So to focus on this area of research, we founded the Responsible Technology Institute that Nigel talked about from an award from industry, and we worked there with a diverse set of stakeholders globally. And I want to give a few examples so that we can sort of see a bit more practically what responsible innovation will do. And I'll start with my fellowship, which is looking at responsible robotics, which is actually one attempt to try to look at responsible innovation in action. The novelty of that work lies in looking at responsibility as a focal topic in the UK's Digital Economy Programme. We're looking at exploring and embedding culture of responsible innovation, where responsibility in this context is much less about individual accountability and liability, and much more about collective care and responsiveness. Questions of responsibility are actually often driven by economic considerations, but these issues run much deeper, and they're implicated in a wide reshaping of institutional, cultural, and democratic responses to governing technology. I think we can already start to see how these things are being reshaped. How to divide responsibilities in the digital economy between developers, civic authorities, users of the technology, and automated systems represents as yet a series of unsolved problems. So on the fellowship, we work with a range of stakeholders like engineers, social scientists, lawyers, accident investigators, and industry, as an outcome of the anticipatory work identifying what could possibly go wrong with robots and other AIs. We're actually developing, in collaboration with Professor Alan Winfield at Bristol, maybe you know him, something called an ethical black box, or an EBB, to be embedded in all social robots. Broadly speaking, these social robots are those that interact with humans on a daily basis. For example, autonomous vehicles, companion robots, toy robots, and so on. The EBB itself isn't hugely sophisticated. It's similar to a flight recorder, but it can continuously record, sensor, and relevant internal status data, and it can be extended to actually also to capture the AI decision-making processes and any environmental factors that occur before a bad incident. This data can provide crucial evidence following accidents and incidents involving robots. It may surprise you at the moment that there are no investigations. There is nothing to investigate any kind of accident with any autonomous vehicles or robots currently. This information then can help us then to understand why a robot behaved in the way it did, and then make recommendations to help prevent it happening again. We're conducting right at this very moment accident scenarios in collaboration with accident investigators. And this is partly because we promote the investigation as a social process, where the EBB is only one part of that process to be considered alongside of other bits of evidence. The EBB is not the arbiter of truth here, it is one other bit of evidence making in the investigation. And on top of that, we're also developing a range of materials to enhance our public dialogue and impact activities, because it's quite hard to get this out. We spent a lot of time thinking how to interact and engage with people who know nothing about this. So we do things like working with artists to create animations of particular research outcomes. We work with youth juries to actually show the different outcomes of different algorithms. And then we've developed sort of cards to actually illustrate and animate, for example, how bias might work in algorithms. It's astonishing how people suddenly start to see where things might change if you choose different algorithms, how it can have such a different impact on them when they're part of these systems. Most recently, on my fellowship with the robotics, we're working with jazz musicians who've written stories about young people based on the unintended consequences of some of the AIs, and they've created jazz pieces based on these, and these are to be used in schools, because they're also trying to promote jazz in schools and music which is sort of not happening either. So what we're doing is, this focus is on vulnerable and marginalised communities, and it's a strong theme of what we do in the RTI. And these are often people that suffer most from novel technologies, and they're particularly challenging to work with. So we work with a large group of collaborators to increase our understanding of the relationships then between digital risk, resilience, and adolescent mental health, for example. And we're developing and evaluating preventative and personalised digital interventions. And here what we're trying to do is develop a framework to help us understand adolescent mental health in relation to novel digital technologies. We're also helping some industrial partners who are developing AI systems for local authorities in particular areas of social care, helping to identify the likelihood of vulnerable people falling in an accident, for example. And again, here are many challenges to do with overtrust, over-enthusiasm of AI systems, and issues of false negatives and false positives. And the final example of what we might be doing in the RTI is looking at the impact of technologies on human trafficking and designing technologies to disrupt that human trafficking online, particularly with people in the global south. So these are the kinds of projects that we're involved in, the sorts of things we're doing. It's all again about responsible innovation and developing that understanding how to develop responsibility in different contexts. So what we're doing now that's slightly more novel is also looking at other aspects of responsibility in digital innovation, such as the carbon footprint of some of these systems, and the neural networks and ChatGPT and all what you're talking about is really carbon guzzling. So we have to think about that in the future as well. The impact of the Western built systems on the global south, the extractive nature of much of the Silicon Valley ecosystem. Many challenges here exist on how to do this, none the least how to measure these carbon footprints systematically and consistently, and how to engage them with the global AI. So this leaves us with a few things to think about. A significant part of responsible innovation then is about engaging with different sets of people, but this is really challenging with hard to reach groups. If you're dealing with migration, if you're dealing with trafficking, sex trafficking, these are vulnerable people in sensitive backgrounds who might be unreachable in the first instance. So we're trying to develop ways to be able to do that much more sensitively. Engaging with government, which is a very important part of what we do, government and policymakers, this can be a painfully slow process due to the formal procedures that are in place and their very busy schedules. And this is in the context of an ever-increasing fast pace of technological innovation. So what we're trying to look at is how do we make this process much more agile, and we work with policymakers to try to think of ways that we can reach them much more quickly, particularly in the light of fast-moving tech. And finally, anticipation is not prediction, and this is a shift in thinking that can be hard to grapple, particularly hard to sort of grasp, particularly for technical people. We're not trying at this stage to predict what is or what will happen, but to anticipate what might happen, to describe and analyse those impacts from a particular animation, and then applying this to existing technological processes is extremely challenging because people have got ways that they actually develop these things very fast. Agile is much more the flavour of the month. So how do we get in there to try to alter the sort of orientation of a particular technology?
Thank you very much. And taking those thoughts in mind, just moving over to you then, John, just to reflect on the issue of responsible relates to values, values relates to ethics. How do we organise our ethical compass in the context of these extraordinary verbs?
I wish I knew, Nigel. But, here are some thoughts. Nigel asked me to talk about the relationship between ethics and the regulation of AI. Some people see a massive distinction there between ethics and regulation. So I think the first thing to say is there isn't a distinction. Any form of responsible regulation ultimately has to draw upon ethical values. Because what are ethical values? Basically, they're values that address two sorts of questions. One question is, what is it to have a flourishing, worthwhile human life? So it's a kind of question of what human well-being is. And another sort of question is the question, what it is that we morally owe to others, other human beings, other animals, the planet, etc. So the question of well-being, the question of moral duty, are fundamental concerns that any form of regulation, whether it's my personal self-regulation in deciding whether to purchase a social robot to talk to my mother, or hard legal regulation that's actually enforced, whichever kind of regulation we're talking about depends upon some conception of ethical values. And a couple of other things follow from this. One is if we're talking about the domain of the ethical, then we're necessarily talking about a domain of deliberation and choice. And unfortunately, a lot of the issues here in AI are often clouded by a kind of technological determinism that something is happening, AGI is on the way, there's nothing we can do about it, and we're thereby reduced in some sense, both individually and as democratic publics, to a position of passivity. This is very similar to the narrative of globalization. Globalization is inexorable, it's going to take a certain course, and we simply have to accommodate ourselves to that. I think it's important to push back against those narratives. And another version of that narrative is tech industry saying the inexorable laws of the market dictate that they behave in certain ways. Again, this is just a way of avoiding responsibility. Another thing to bear in mind when we think about the ethical in this way is that the ethical encompasses the positive reasons for doing certain things, not merely negative prohibitions against doing them. So it was very interesting when we had Tasioulas give us a lecture last year, and he talked about all the wonderful things that AlphaFold could do in determining the structure of proteins and help us address certain diseases or certain forms of plastic pollution, save the honeybee, etc. And then towards the end of his lecture, he said, well, now I'm going to start addressing the ethical questions, as though he wasn't already addressing the ethical questions, because presumably all the things he was saying AlphaFold could do are worthwhile things. But unfortunately, we don't tend to put under the microscope the question, what is this application being used to do? What good is it bringing about? And often when we do ask that question, as in, for example, the recent white paper produced by the UK government, the naive assumption is that economic growth is the objective. But economic growth can never be an ultimate objective. There are all sorts of despicable practices we could encourage that would promote economic growth. But wealth per se is not valuable. It's merely a means to something else. And unfortunately, that sort of issue tends to get crowded out. Another thing I think it's worth mentioning is that there's often this assumption, because we're dealing with the new technology, therefore, in terms of regulation, we have to start from scratch because this is an absolutely new technology. This is a tremendous mistake, I think, and we have wonderful legal scholars in Oxford and elsewhere who have pointed out that there is an existing structure within the common law, wider legal principles that have to be thought about, human rights principles, before we attempt then to add novel forms of regulation. And one of the reasons here is it's a mistake to think that new regulations create greater protection necessarily. In fact, they may undermine existing protections. If new regulations are created, they're going to be created in a political environment where tech companies wield massive power and are able to influence what those regulations are. And often those regulations will displace more powerful protections that already exist. And there are reasons to think, for example, that the EU's AI Act falls into that category, that for various reasons, including treating this as a matter of product safety rather than a matter of human rights, you end up getting an inferior level of protection, as argued by my colleague Jeremiah Sadams-Prassel. There's also the worry that the AI Act depends upon being able to identify in advance certain domains where there's a high risk of human rights violation. But can we, a priori, identify the domains where there's a high risk of human rights violations? It seems to me that pretty much in any domain of life, there could be a risk of, for example, racial discrimination against someone. So the whole structure becomes problematic because it's trying to displace an existing regulatory structure that we haven't fully explored the implications of. Now, I just want to conclude by mentioning two sorts of issues that in the Institute for Ethics in AI that I direct, we've been thinking about. And there are various ways in which you can think about the challenges posed by artificial intelligence. Some of the challenges AI poses simply exacerbate existing problems we already have. So problems with predatory capitalism or with political polarization. But other challenges posed by AI are kind of sui generis to AI. So I want to focus on two of those. So one of those is technological unemployment. Now, of course, you'll say all sorts of technologies have generated the risk of unemployment. But I think with AI, we're talking about tremendously different level of scale at which human labor might be displaced. And one of the boons of AI to philosophers has been that it's forced us to think about questions we ought to have been thinking about long ago, but have sidelined. And one of them is, what's the value of work in a human life over and above the money you get for working? Okay? Serious question, because if there's going to be the prospect of massive technological unemployment, if there's value to work over and above the income you derive, then a UBI, universal basic income, is not going to provide the answer. So one thought would be, look, central to the value of work is the notion of achievement, of engaging in a difficult task in order to bring about something worthwhile, okay? This is valuable in itself. It also promotes a form of self-respect in people. And this self-respect is probably also integral to the ability of democratic citizens to look each other in the eye as equals. Now, the problem is twofold. One, AI systems could replace human work activity. But even if they don't, the mere fact that you know an AI system could be doing the job you're doing and doing it more efficiently renders it kind of meaningless. It's a bit like those fake jobs created by the Soviet Union. So the question then becomes, if we're going to have the shadow of AI over us, undermining this major source of achievement for many people, what could replace that? And one thought that a number of philosophers have put forward is, in the post-work utopia, we'll be playing games. So we'll have a world where work is replaced by gameplay, okay? And that raises many interesting issues. What's the core value of play or gameplay? A lot of people, a lot of distinguished philosophers think it's achievement. And if that's correct, then games can substitute for work. But for me, that's a very sort of puritanical American conception of gameplay, that it's just another form of work, another way of achieving. I like the old European idea that play in itself is a value. And if play in itself is a value, then it's not going to be clear that games are going to substitute for work. But even if you say, look, yes, okay, play is the key value in games, but nonetheless there can be people who achieve in game playing, like in chess, for example, Then there's a further question, which is typically in work, the achievement involves bringing about some independent end that is worthwhile, like health or justice or sanitation or whatever. And it's not clear that with game playing you're going to get that. Now, of course, philosophers have taken this even further. One of the most distinguished philosophers writing today, my Australian compatriot, David Chalmers, has written a book, Reality Plus, where he says, not only will we be playing games, we'll be playing these games in virtual reality. And Chalmers puts forward the point that for him, a life lived in virtual reality is just as valuable as a life lived in the ordinary reality we experience here and now. Okay? So he imagines the idea, you upload yourself to a computer, you spend your time playing games there. It's a lot more fun because there's no resource scarcity in the virtual world. Everyone can own a mansion, everyone can be a billionaire, you can fly, you can't fly in ordinary life, etc. Interesting question that arises there. Not just about achievement, but about contact with ordinary physical reality. If you go back to philosophers like Hegel and Marx, one of the things they said was valuable about work was that it brought us into contact with a recalcitrant, independent reality that we tried to humanize. Compare that with living in a world that's already been synthesized by human beings. So that's one kind of question, and let me conclude with another sort of question that some of us are thinking about, and that is the general question of, does AI necessitate that we transform some of our human rights thinking? So this could do it in various ways. It could be that rights to privacy ought to be reduced, because if we could generate massive benefits, health benefits, for example, by using people's data to have personalized medicine, then maybe privacy protections ought to be attenuated to enable those benefits to be achieved. Or maybe we need new human rights. You know, having heard David Chalmers, maybe we want to right access to reality. Or thirdly, maybe we need to think about new bearers of rights. Would AI systems have rights under certain circumstances? Or maybe big tech corporations have human rights responsibilities and not just governments? So one of the issues that I think is very interesting is there a right to a human decision in certain domains? And we see that come up in the GDPR, where there's a right not to be subject to an automated decision in certain contexts. And in the White House's recent blueprint for an AI Bill of Rights, they talk about a right to opt out of being subject to an automated decision. So this, I think, is a fascinating area. There's a thinker that both Nigel and I very much admire, Joseph Weizenbaum. He wrote a book called Computer Power and Human Reasoning. He said, look, we should forget about the sterile debate of trying to figure out what AI can or cannot do. The real question that this distracts us from is what it should be able to do. And so one of the ways in which, so of course, not all of that is about rights. So for example, someone who uses an app to decide who to marry, right? They're probably behaving in a very insensitive and perverse manner, but they're not necessarily violating anyone's rights by doing that. But when will it be a rights violation to use an automated system to make a decision about someone? For example, in the case of criminal sentencing. Now, one thing we have to think about here is there's a bunch of arguments on the other side that say, number one, the automated system is going to be much more efficient. You're going to get the decision much faster and more cheaply. They're going to talk about consistency. The algorithm will be much more consistent. In America, the asylum system is such that there are some judges who allow 8% of asylum applications, others allow 88%. Now that seems prima facie to be a massive injustice, because whether you get granted asylum really depends on which judge hears your case. Presumably, an automated system will not display this kind of noise, as Kahneman and others call it. And then there's also the possibility that maybe the decisional outcomes would be better. So in the case, people talk about AI being a black box, but you can, in fact, try to adjust the model in order to bring about better outcomes. You could try to iron out unfairnesses in a way that might not be possible with the human being. So against that background, I think an important question is, what are the considerations that drive us to say, sometimes there is a right to a human decision. And I think a lot of them won't be about the output, the decision, but the process. We want the process of decision to be respectful, to be thoughtful, to be a process where the decision maker can take responsibility for the decision made, where there's a possibility of empathy and solidarity between the decision maker and the person subject of the decision. And those things aren't straightforwardly available in the case of an automated system making a decision about you. But that's just some of the things that we're thinking about under the rubric of an ethically sound regulation of AI.
That's great. Okay, so we had a fairly extensive set of views there on the from different perspectives on how this might play out. I'm keen that we kind of go around at least a little bit more and then perhaps open up to the audience. Actually, I guess to you, Jacomo, I mean, this issue, we're bound to raise it, of scale. Scale, the engineering complexity of these modern systems is such that, well, you talk about the amount of compute, you know, that Palm, the very large foundation model from Google, was trained on, you know, 6,400 tensor processing units. This is an inconceivable amount of compute power for most organizations. The scaling seems to suggest that inordinate emergent phenomena emerge. There's some interesting evidence that you can actually prune back these models and get effective models on smaller sizes and scales, but even that takes a lot of effort. What's the kind of story here about, if you like, the role of business deployment, where potentially there's a real issue around who has control of the compute to do the kind of work we're seeing emergent systems give rise to? It's a very large amount of compute. Does that give you any cause for thought?
I mean, I think a lot of the concerns that we have maybe about, you know, having to regulate the development of this technology is precisely, you know, because of what you described, the level of emergent phenomena, and we don't know exactly what a GPT-5 would look like, nor exactly what tasks it would achieve state-of-the-art performance on, and what other behaviors, you know, would arise next to that. And you're right. Like, once you have the story of the last few months is that once you have one of these very large models, like, there are mechanisms whereby we're able to commoditize these models and achieve, you know, commensurate performance, almost equivalent performance across a large set of tasks in models that are 1 or 2 orders of magnitude smaller. And so, you know, and there's the self-instruct paper on the one hand. There's also, domain adaptation by task distillation, just to name 2 different mechanisms where we've learned how to take these large models and to get at equivalent performance on much smaller models, which in a way is democratizing now that tool. You know, for some of the larger tech companies in OpenAI, Microsoft, Google, you know, that is very quickly commoditizing the investments that they've made in infrastructure and in compute. You know, for the open source community, I think it's, you know, something very exciting, but it's also something of concern at the level of, once we have one of these models that exhibits certain behaviors, that a lot of that could now be very, very difficult to regulate. You know, a few weeks ago, you had Sam Altman before that Senate hearing talking a little bit about his model, his conception for regulation, and maybe his plea for regulation. And he talked a little bit about an International Atomic Energy Agency like model, which I don't think fits for a number of different reasons. I'm actually, you know, a lot of the work that I've been doing over the course of my career has been in a B2B context, in enterprise. What PhysicsX is specifically concerned with now is really in the space of physics. So, you know, think of generative models that take advantage of, you know, deep learners that approximate physics, so physics foundation models. And, you know, I think with the development of this technology, like, I think what's much more appropriate is a little bit more of a, you know, a simple KYC model for regulation, that in certain domains we would know who is building certain categories of models, at least on the very big clouds, and maybe some of the federated GPU specialist clouds and other infrastructures, precisely because the amount of compute required to that has to be mobilized is such that I think it is achievable maybe to at least understand who are the actors who are trying to develop these foundation models. And I think beyond that, the only other regulation that I think there's some imperative, or at least some degree of urgency around, is more in consumer applications, much less enterprise deployments, because enterprises have a risk function. There's, they're even in non-regulated contexts, like they worry about liabilities, they worry about GDPR, they worry, and I worry much more about the effects of a lot of this technology when the individual is interfacing with those technologies, is consuming them. Like, do we necessarily need much more hyper-personalized advertising content? Like, the fact is that the efficacy of these models, and that is there is money to be made from their deployment in a lot of B2C contexts, I think suggests that we should think a little bit about regulation there, and maybe existing legislation, as much as it's a starting point and we shouldn't throw out the baby with the bathwater. I also think there's an argument here to really think about whether it's the FTC, the FCC, but existing Ofcom, like existing regulatory bodies, thinking about how they are going to adapt maybe existing regulation. I don't necessarily think that these are acts of parliament that have to be passed.
So that's a very interesting point. I mean, I know in the UK, the Competition and Markets Authority, the CMA, will have a new set of powers around the Digital Market Act. Digital Market Unit is looking for this notion of strategic status, strategic market status. Companies that have so much incumbent power that in some sense they can have essentially what the FTC looks for, a monopolistic position. The challenge, of course, is that this new emerging capability is generic. It's a general purpose technology, and it can be specialized. Back in the day when we used to handcraft our expert systems for task X and Y, you were building this mammography system, a system that would check X-ray. You absolutely knew what the kind of schedules were, what the kind of appeal to a set of existing law and licensing and practice would look like. Here, there are so many materializations potentially, and that's what you're pointing to. So, Marina, to your point, how do we anticipate risk when the landscape is now so broad? Do we just have to be vigilant to where things are beginning to emerge, or where sectors are taking this thing and particularizing it?
Yeah. I mean, I think one of the things is that we need to have as many stakeholders as possible discussing these things, and continuously, because it's happening so fast. That's the problem. That's one of the things I was saying at the end about responsible innovation. It's so difficult in that respect. You have to have the people with the expertise, but also the people who can anticipate what might happen according to that. And we're doing it now. This is a bit of responsible innovation now, because we're sitting around and talking about the consequences of these things. It's very interesting to hear what your perspective on this is. But then how do you take it forward? I mean, we want to take it forward in many ways to get developers to start to think about these things. And we've started to train with Orbit, as you know, we're training a lot of the new doctoral students to start to think about some of the consequences of what they're actually developing, what they're doing. Because they never had to before. It was just, fiddling with this little bit and there it goes. But now it's much more impactful on society almost immediately. It's not a simple answer, Nigel, but I think you need to get as many voices as possible, different kinds of voices around the table, to work out what the implications might be to do that.
But I would just say one thing, which is as much as it's important, I think, to have a degree of inclusivity at the level of who's thinking about the problematics around the rollout of this technology. I also think it's incredibly important to sort of orient that towards the engineering of it. and to think about, what are the tools that are going to be at the disposal of these engineers, these developers, that are going to allow them to safeguard these systems. What are the tools that are going to allow us to, better audit models, or at least understand their behavior? One of the big issues that we have is that, I think this applies to AI safety as much as it applies to, let's say, fair, accountable, and transparent AI, ethics and bias issues, is that the tooling to ensure that, by which we scrutinize a model and understand its behavior is incredibly limited, right? And I would call out just like the, latest, like the Mozilla AI, project as something that's at least moving the dialogue towards thinking about what the implications are for tooling.
That's a great point, and I think it speaks to another issue that I think we might want to touch on before we go out to the audience, which is, I mean, at this very moment, you could say that a lot of the field of AI machine learning has really benefited from an open source movement. But at the moment, we're also seeing a reluctance of companies, for all sorts of alleged reasons, not to want to necessarily expose some of the tooling, not all of the tooling, that's very specialized. So that's going to be an interesting tension. I guess coming to John, just interesting issues around ethics, and just to speak to some of the interests I know in the audience, which is, we talked a lot about the AI or the machine learning as a system somewhat that we interact with. But there is, of course, a lot of interest, Musk's recent work on Neuralink, all sorts of issues around potential more invasive ways in which the machine and human condition might be intertwined. And I wonder what are the ethics around the notion of, if you like, our cognitive dignity, about how we may or may not be surveyed or variously interface with our systems. Is this something that you think is an appropriate thing for the ethics to be grappling with, these kinds of ideas?
I think this is actually quite a profound problem, because ethics doesn't sort of emerge in the abstract. It's tailored to the human condition. So the ethics that we have, painfully built up over centuries, some of it right, some of it wrong, but that ethics is based around fundamental features of the human condition, like our mortality, for example. That was an interesting feature of Chalmers' idea that we can live in virtual reality. In virtual reality, you could be immortal. But now the question is, if you're then talking about a transformation of human nature in that way, that's fundamentally a leap in the dark ethically. Because if our ethics is attuned to our human nature, and we abolish our human nature, then it's not clear that we're in any sort of environment where it's clear what's morally good, what's required. Think about the ancient Greek gods, right? They had a bunch of capabilities humans didn't have. They also were terribly amoral, and that's probably related to the fact that they lacked these vulnerabilities. So I think for me, this is quite a fundamental question. In AI ethics, are we proceeding on the basis of what is fundamentally a humanistic ethic?
And would you extend that to, I mean, there's been a lot of talk about the use of AI for posthumous representation of the beloved and deceased. You know, these are areas which are very much in view. There are companies standing up some of these services, and you ask yourself, is part of the human condition to grieve for, and in some sense become more remote from the person you've lost? I mean, we don't have to reimagine a virtual world to see a world very much coming into view where our condition might be really changed.
This is absolutely right. And many of the things that, you know, in some sense are painful and nonetheless valuable. I mean, it is right and proper to grieve for a lost loved one, right? And the inability to do so is problematic. Losing that capacity because you have some sort of simulacrum that can be put forward as the loved one still being in existence can be thought of as a diminution. Now, I don't want to come across as being radically conservative here. I think part of the point that I'm making is it is a huge leap in the dark. And with a lot of these issues, actually, we're not going to find out the truth except through suffering the consequences.
I'd like to go to the audience now, at least for a few minutes before we bring this wonderful symposium to a close. And rather than handing mics around to take an age, just get up and bellow, and we'll represent it if we can't hear it. Yes, please. Yes.
Hi, I'm Melissa Hinton. I'm a senior reporter at IQ Tech Review, and I'm moderating a couple of panels here today. And really enjoyed this conversation. And talk about AI posing an existential risk to humanity. We'll develop technology that will kill us all, and tech CEOs pushing to mitigate these risks. Just today there was a letter, another letter. So what do you think about this? What do you think of this moment and these arguments? And
The existential threat, stop the clock. Absolutely, yeah, no. Let's quickly get a sense of that, because I must say I think we have been there before, but maybe the voice wasn't quite as loud. I mean, there have been various times when people had basically predicted the demise of work, an existential threat in terms of they would decide to do away with this. I have to say that my sense is that the capability of these things to become, of systems to become capable across a broad swathe of tasks was in a certain sense the defense, because it was so difficult to imagine getting to that place. I think that may be one of the differences, that we have this huge general capability and it could get specialized in very quickly into lots of ways, some of which may or may not support human flourishing. But for myself, I think it's about being agile about the response methods to work out how we scrutinize, survey, and respond, rather than saying, stop the clock. I've not seen an example in technology where possibly you could argue in some bio application areas where simply the law was passed to prohibit certain sorts of experimentation. Let me ask my colleagues, what's your sense of where we are? Is this different? Is this an opportunity for pause and reflection, or are we just going to have to deal with it on the fly?
So in the first place, it's worth saying that there's no consensus view here, right? And so a lot of the people who are in tech, like on one end of the spectrum, you have people like Schmidhuber, who will say that there's nothing to see here, and all of this is incredibly benign, or at least like for the foreseeable future is benign. You have people a little bit to his left, like even Jan LeCun, who I think are on the side of less worried about things. And then I bet you've got people like maybe Jeff Hinton, who's voicing a great deal of concern about the development of this technology, right? And I'd say Sam Altman is a little bit to his right, in that at least he aligned to a number of senators' concerns about their technology. I don't know how sincere that was, but he's at least voicing that we should be relatively concerned. I'm on the spectrum. I'm certainly, and maybe this is also driven by peer effects and the people I'm immediately surrounded by, but I am, this is different, I feel. Like, I think we do have reason to be concerned about where this technology, will lead us. There's something fundamentally different about these models, and the ability to be able to, to generate content, right? And not just language content, but across a range of tasks, even the level of video, voice. And the thing that has me worried is less some far-sighted view of, AGI and the lack of control of this technology. I'm less concerned about that, at least in the near term. My concerns are much more nearsighted, and it's much more around, what happens a little bit to, to society, right? As we start interfacing more and more and at scale with so many of these models. The reality is that, we have so many built-in reflexes, even if we know that something is a robot, we're still prone to interacting with them in virtue of their, communicating with us in speech and what looks like human speech. We still relate with them as we would a human, and I think that's a bug in our hardwiring, in our when GPT-3 was released, and you might remember, a lot of people posting interactions with Sydney, for example, and the way in which Sydney behaved, but also the reactions that Sydney elicited in a lot of the people that that interacted with this bot. And And just think about that at scale. As much as we might be concerned with misinformation, with, with the effects on mental health, and at any age, with human-generated content modulated by these recommender systems. There's something fundamentally different when you completely close the loop, and when now you have synthetically generated content that's hyper-personalized to you, and what will be effective and efficacious in driving your behavior and steering your behavior in one direction or another. And it's precisely those applications that I'm more worried about.
That was such a good question that we're taking a bit of a time to answer it back, but just some quick thoughts. Yep.
Yeah, I would agree with that. And I think there are ways in which we can actually mark these technologies to show that they are not. Where's the protocol? Mark them so we know, watermarks them, that we know where it's come from. But I think there was a really nice article in The Economist just recently written by a professor at Leipzig, whereby he was likening the cybersecurity went through the similar kinds of concerns and worries, and existential worries, and the ways in which they handled that, which actually didn't happen, but also the ways in which that. So there are lessons that we can learn from something like cybersecurity. How to calm this down, really, because I think it needs calming down. But also, I think we need to have just slow down a little bit, for goodness sake, yeah? It's not a question of stopping or pausing, it's just slow it down. And there is a movement, particularly in responsible innovation, to go slower. Yeah? I think that would work.
Thank you, Nigel.
Yeah. Just on the existential point, I mean, one can't just rule out an existential risk no more than I might get struck by lightning walking home. But I think one ought to examine some of the premises. One of the premises is artificial general intelligence poses this threat. But notice the definition of intelligence is incredibly constrained. I mean, on this definition of intelligence, you could be totally amoral and have general intelligence. Well, can a being that was totally immoral really replicate human cognitive capacities across their entire range? I'd suggest that across the entire range of human cognitive capacities, there are many value judgments that one would have to make. So already we're dealing with a very sort of etiolated notion of what intelligence is in order to get this off the ground.
This is a very rich conversation. I want to get a sense of how many questions might be in the room. There's 1, 2, 3. I'm going to take those 3 questions because I've seen them, and then we're just on the hour. Won't detain you too long from your drinks and other things. Yes.
There have been a number of papers recently that have been saying that there are deep problems with deep learning. No one understands exactly how it works. Now, one of the interesting properties of humans is that they can give you reasons for their behavior. And in a sense, we don't have that from deep learning. They're mostly derivative issues. We give reasons for our behavior, and then we hold someone in terms of their actions as to whether they're obeying the reasons they've given for their behavior. So surely that's one of the things. And what I'd like to ask, particularly the first panelist, and perhaps our chairman, is the extent to which artificial intelligence systems are already beyond that and are able to give reasons for why they do things.
Thank you very much. I mean, I just say that I think, of course, there's always the kind of canard, which is that sometimes the reasons we give aren't always, in any sense, rooted in what actually is going on, or they may be plausible fictions. But in the general case, absolutely right. I think that humans can give reasons and evidence-based reasons as well, at least in their behaviour. Yeah.
The point I made, Nigel, is that then we hold people
to account. Yes, absolutely. Yeah. Well,
I mean, that's a little bit what I was trying to describe with saying, like, with GPT-3 and its capacity for, chain of thought reasoning. This is a phenomenon by which, or, the ability by which you can ask the model to basically spell out, how it's solving a problem, to reason, step by step, and that in doing so you improve the performance against that given task, against that problem. And this is a it's only from GPT-3 that we start seeing this kind of behavior exhibited. And that's not necessarily something that we expected large language models, like a property of large language models. So again, I come back to my point that there's something fundamentally different about these very, very large models and how they behave. And I think we are now in a place where these very large models, we can at least, we can probe why they provided a given answer. We can ask for, it's not just at the level of providing citations, but for complex reasoning tasks, we can ask for, some kind of, exposition and elucidation of, how it arrived at an answer. And you're exactly right that the phenomenon by which it arrives at that answer is not something that we know how to audit, right? And so that is also fundamentally like one of the things that's different about these models and how we probe them. If you think about, very traditional machine learning models like a, decision forest, like random trees, XGBoost model, these large ensemble models, we would have ways in which we would look at, Shapley values and marginal relevance scores to see what features were weighted making their way into a model, and we'd have, people would come up with local surrogate models, right, or global surrogate models, but we'd have some way of inquiring, like how, why a given prediction was made. And with these very large models, our toolkit for even inquiring, why a given answer was given, why certain, why a picture was painted in a certain way, to relate that back to the prompt, I think is much more mature.
The engineering is well in advance of the science in that regard. It's a fascinating point. I'm going to release you all at 1:30 on the dot, I promise, but 2 more questions. Yes.
There was a war that was recurring in all talks, or many of them, is accountability. So do you think AI, as it becomes more and more an active agent or a component of society, can ever be held accountable?
That's a great question. Can AI be held accountable? That's a good to John.
It depends on what kind of capabilities it can develop. I mean, as the point was being made earlier, being held accountable is partly about being able to give the reasons for doing what you did. And so it could be the case that there's in some sense in which an AI system can explain why it did what it did, but will it give reasons that justify what it did, or will it just give a causal story about the factors that led to the decision? So there's an AI system used to predict patent litigation in the US, and its predictions are as good as the best patent lawyers. But it doesn't use the law to make the predictions. It uses things like, who are the lawyers in this case, and what's the value of this case to make the prediction. So those considerations don't justify the reasoning given. Now, I can't rule out as a philosopher that there couldn't be a development. But I think also we have to bear in mind that always, at least in any AI system we know now, there are humans who are responsible for designing it and humans who are responsible for deploying it. So there's always accountability, even in these cases. We mustn't let the system obscure the fact of the humans in the background.
Marina, I guess that's at the heart of responsible initiative, right? Is about accountability, right?
It's about accountability, and also, in the sense what I was trying to say earlier on, that there are many people, many voices in this, so there are users as well. How you use that system, some of that responsibility is on you too. If you're driving a driverless car, for example, and not paying any attention to what you're doing and you crash it, or it crashes because of your actions. So, but mapping out those levels of responsibility is still quite complex.
Final question.
It was a great system, it really did work well. And I think a few of those at that time were. And it was, I think the government put 6 million into developing about 3 or 4 of these systems because we were worried about Japan at the time. We thought Japan was going to overtake AI. And it was a really, really good system. And it developed, it allowed for a lot of new thought coming out. Lucy Switzerland's book on plans for situated action was a critique of AI. What does situated mean? What does it mean when you're making decisions in a particular way? It would have been great if it could have been. We wanted to put it on a bus, yeah, because nobody had a computer at that time. So we wanted to have a travelling bus for people to be able to understand how to claim more benefits. But it was not to be, I'm afraid.
Sometimes it's back to the future. You sometimes feel that those kind of applications could well be studied again in the context. Look, we're at half.